Alright, in this video I will introduce you to basic probability, and I will explain the difference between overlapping events and events that are mutually exclusive. So first let's talk about mutually exclusive versus overlapping. When we're talking about probability, we talk about events, and when you hear the word event, it sounds like something exciting, like you're going to go to a football game or something like that, maybe a concert, an event. But when you're talking about probability, an event is really just a situation. So consider the following three events, the following three situations. Event A is the situation where you have an A in math. Okay, so you have an A in math. That's event A. Okay, event C is you are passing math. Alright, not as great as event A. And then we might as well call it event F. I think you know what's coming. You are failing math. Wah, wah. Okay, these are the three events, the three situations. Now, we would say that event A and event C are overlapping because there can be a student that has an A in math and is passing. So there's a student who can be in both of these situations at the same time. So A and C are overlapping because some students are passing and have an A. So overlapping events are events that can be happening to the same person at the same time. Okay, on the other hand, events C and F are not overlapping, so we call them mutually exclusive. There are no students that are both passing math and failing math at the same time. You cannot be in both situations at once. So these are mutually exclusive because no students can be passing and failing at the same time. Alright, so that's the basic concept of overlapping versus mutually exclusive. So let's look at a couple problems. So, event A. A person has ridden a roller coaster. Event B has ridden a Ferris wheel. So, what do you think? Mutually exclusive or overlapping? Hopefully you were thinking overlapping because a person may have ridden a roller coaster and a Ferris wheel. Alright, did I spell Ferris wheel right? Yes. Okay, what about number 2? Has brown hair, has brown eyes. What do you think? Mutually exclusive or overlapping? Alright, we're going to go with overlapping again because there could be a person that has brown hair and brown eyes. Okay, what about number 3? Event A is a sophomore, event B is a junior. What do you think here? These are going to be mutually exclusive because you can't be a sophomore and a junior at the same time. Okay, what about number 4? Has shoulder length hair, is male. These events will be overlapping because a person can be male and have shoulder length hair at the same time. Okay, now let's talk about basic probability. Out of 220 people who came into an Italian deli on Friday, 104 bought pizza and 82 used a credit card. Half of the people who bought pizza used a credit card. So I think the best way to make sense of this is actually to make a Venn diagram. So this rectangle represents all of the people, the 220 people who came into the deli on Friday. Now, some of them bought pizza, some of them used a credit card. So I'm going to make a circle for those two events, those two situations. So this circle represents the people who bought pizza, and this circle represents people who used a credit card. So now 104 people bought pizza. So I've got this number 104, and I need to think about where that's going to go in my diagram. But if you look at the pizza circle, it's got two regions to it. It's got this part of the circle right here, and this is where the people bought pizza but they did not use a credit card. But then it also has this part right here that's in the overlapping part. These are the people who bought pizza and used a credit card. So I can't just put 104 in the circle anywhere I want. I'm going to have to actually split that 104 up. So how will I split it up? Well, they told me that half of the people who bought pizza used a credit card. Alright, so half of this is going to be 52. So that tells me that, let's see, can I erase this without messing up my diagram? So the people that bought pizza, 52 did not use a credit card, and 52 did use a credit card. Okay, if I add those together, I get 104 people who bought pizza. Now, on the other hand, 82 people used a credit card. A common mistake would be just to put 82 right here, but that would be wrong because I already have 52 people that used a credit card that I've already written down. So if I put 82 over here, that would be, like 134. So that's too many people. So I need to do 82 minus the 52 that I already wrote down. So that's going to leave 30 people in this group, in this region over here, who used a credit card but did not get pizza. So now those two numbers together, the 52 and the 30, that makes the 82 people who used a credit card. Okay. Now, so far I have 104 and then plus another 30. So far I have 134 people represented on this diagram. But there were 220 people who came to the deli. So I need to do something with those remaining people. They go out here. So what is 220 minus 134? Okay, so that's 86. So I'm just going to put my 86 right there. Okay, now I can use this Venn diagram to easily answer these two questions. One more thing. Sometimes they ask you about probability, and sometimes they ask you for a number of people or whatever. Whenever they ask you for probability, I encourage you to think of it this way. Alright, I think of probability as target over total. Alright, the target is the thing that you're trying to get, and the total is everything. Okay, and you can express your answer as a fraction, a decimal, or a percentage. So target over total. Okay, so what's the probability that a customer bought pizza or used a credit card? Okay, so if we're talking about they bought pizza or used a credit card, that's all of these numbers put together. Alright, now I've just highlighted the target. Okay, the word or means we're looking for the union of these, not the overlap. We want both circles. Okay, so that's the target. So how many is that? Because we're going to do target over total. So that's your 134. Okay, so I've got 134 people who bought pizza or used a credit card, divided by the total of 220 people. Okay, so now we just do target over total. So this reduces down to 67 over 110 if we just divide both these by 2. So that's one form that you can write your probability as a reduced fraction. Or as a decimal, this would be 0.609, approximately. Or if I move the decimal point twice, this would be 60.9%. Then number 6 asks how many people neither bought pizza nor used a credit card. Alright, so they're asking for how many people are not within this union that we just highlighted. And so that's the 86. 86 people neither bought pizza nor used a credit card. Alright, so notice it says how many, so we're just putting a number, not a fraction, a decimal, not a percent. That's just for probability. Okay, what is the probability a customer neither bought pizza nor used a credit card? So now they're asking for a probability. So now we're doing target over total again. So the target is the 86 that we just mentioned. Alright, and again the total was 220 people. So we're going to write this in the three forms: fraction, a decimal, and a percent. Alright, so first the fraction. So again, if I just divide both of these by 2, I'm going to get 43 over 110. So that's one version of the answer. Now, I can turn this into a decimal. I'm just punching this into a 4-function calculator. So 43 divided by 110. Okay, so the decimal I'm getting is 0.3909. Okay, so that's the decimal form. Now, moving the decimal 2 places will give us the percentage. So this would be the same thing as 39.09%. For number 8, they want us to describe the differences between number 6 and number 7, both in the way the questions were asked and in how you answer them. Well, for number 6, we're just being asked for a number of people, whereas for number 7, we are asked for a probability, so we must divide by the total. In a survey of 15 students, here are the results. 9 students own a bicycle, 7 students own a skateboard, and 4 students own both. Let's carefully complete a Venn diagram for this information. So circle B is own a bicycle and circle S is own a skateboard. So of course the overlapping part will be the students who own both. We should probably do the overlapping part first. So 4 students own both, so we will definitely write a 4 in there. Now, 9 students own a bicycle, so a common mistake would be to put a big old 9 right here, but that would be wrong, because that puts the 9 and the 4 in the bicycle circle. That would be 13 students owning a bicycle, but we only want 9. So we need to count the fact that we already have 4 written down. So if we want a total of 9, that means there should only be 5 out here. Alright, because that's a total of 9. Similarly, we want 7 students to be owning a skateboard. We already have 4 written down, so that only leaves 3 left to right in this region over here. Okay, now there are 15 students total. How many have we accounted for so far? So that's 12. So that means there are an extra 3 students unaccounted for, and they belong in this part of the diagram. Okay, so now we're going to shade the intersection of B and S below. And again, this symbol means intersection. It means B and S. So that's going to look like this. Okay. So now they want the probability of what we just shaded. So remember, when you think about probability, this P right here means we're doing probability. That means we're going to do target over total. Okay, the target is this overlapping area, B and S, and we decided that that was 4. Okay, so when we do target over total, we're going to do 4 over the total. Now the total is the 15 students. So that's going to be 4 out of 15. So this is one form of the probability right there, a reduced fraction. Okay, now I'm going to get into a habit of showing you all three so you can get comfortable with all three. So if I do a division in my 4-function calculator, so 4 divided by 15, as a decimal I'm getting 0.2667. Alright, I'm having to round a little bit there at the end. Okay, or if I move the decimal point twice for the percentage, that would be 26.67%. So then we're also being asked to explain in words what this represents. So this represents the proportion of students who own a bicycle and a skateboard. Remember, we were doing the probability of B and S. So 26.67% of the students own a bicycle and a skateboard. Okay, let's do something similar for number 10. So here we're supposed to shade the union of B or S. Okay, so when you're doing the union, you're not looking for the overlapping part. You're going to shade everything that is in either set. So B or S. So we're going to shade all of B, and we will shade all of S. Alright, because that's what it means to do a union. Okay, so that's the union B or S. So again, we are being asked for the probability. So again, we're going to do target over total. So the target is what we just shaded. So let's look back at our diagram that has the numbers. So that's the 5, the 4, and the 3. That's a total of 12. Okay, so target over total, that's going to be 12 over 15. Okay, so we will express this in our 3 ways. First, a reduced fraction. Both of these are divisible by 3. So that's going to give us 4/5. Alright, so that's one way of expressing the probability. 4/5 as a fraction is going to be, well, as a decimal is going to be 0.8. Alright, 0.800 is exactly 0.8. So that's another form. So moving the decimal point twice as a percentage, that's going to be 80%. Okay, so what does this mean in words? This is the proportion of students who own a bicycle or a skateboard. And there you go. Alright, so let's see what's next. For number 11, we're supposed to shade the complement of B or S. Okay, so notice we just shaded B or S. So this little mark here means the complement which means that we're going to shade everything but that. Alright, this means not B or S. So we're going to shade in everything around this now. Okay, this is what the complement would look like. Okay, that's pretty good. Alright, so this is not B or S, the complement of B or S. Okay, so again, we're being asked for the probability or the proportion. So we're doing target over total. So how many are in this region? Well, that's the 3 that's in this outer zone. So that's the target. So target over total, we're doing 3 over 15, which obviously it reduces down to 1/5. So that's one way of writing the probability. That as a decimal would be 0.2. Alright, so that's another way of writing it. Now if I move the decimal point twice, another way of writing it is 20%. So those are the 3 ways of writing probability. Now, so these represent the proportion of students who own neither a bicycle nor a skateboard. They don't own either one. So there you go. Okay, what's next here? A group of 60 students were asked if they played football, set F, basketball, set B, or soccer, set S. This diagram displays the results. Okay, so let's shade the intersection of B and S. Okay, so here's B and here's S. So the intersection of B and S is going to be just right in here. Okay, now we need to find the probability of being in B and S. Okay, whoops. So we're looking at these numbers right here, all right? Because those are the numbers that are in B and S. So that's 8. So when we're doing this proportion or probability, remember that we will be doing target over total. Okay, so in this case that's going to be 8 over. Now in the problem they told us that there were 60 students that were asked. So it's going to be 8 over 60. Alright, and as always I'm going to write this answer in 3 different ways. So if I divide both of these by 2, that's going to be 40 over 30. So that means that that's not far enough. So let's divide both of these by 4. So that's going to be 2 over 15. Okay, so that's one form. Now, I'm grabbing my 4-function calculator. You know what, do I have a calculator here? I'd like you to be able to see if you can. So what am I doing? 2 divided by 15. So 2 divided by 15. So I'm getting 0.133, repeating. I'm going to hold it to 4 decimal places. So I'm going to do 0.1333. So that's the approximate decimal. If I move the decimal point twice, that would be 13.33%. So those are my 3 forms of this probability. Okay, what's next? For number 13, we're supposed to shade the union of F or B. Okay, so F or B, so we're doing the union, so that means we're going to shade everything that's in F or B. So we're not worried about the overlap. When we're doing the union, we're just going to shade them all. Everything that's mentioned, F or B. So that's what the union of F or B looks like. Now, what's the probability going to be? So, let's get all of the numbers that are in this region. Okay, so the numbers that we're dealing with are all of the numbers that are within this region right here. Alright, this is the region that we just highlighted in the small picture. So how many is that? Just take a minute and add all those up. Or if it's quicker, it might be quicker to do, since we know that the total is 60, the only numbers that are not in the picture, that are not shaded, are the 10 and the 11. Okay, so that's going to be 50, 40, 39. Okay, so again, target over total. Alright, all of these numbers shaded, that must add up to 39 out of a total of 60. Okay, these are both divisible by 3. So this is going to reduce down to 13 over 20. So that's one form of the answer. Okay, so now let's do 13 divided by 20. Oh, 0.65 exactly. Alright, so that's another form for the probability. And if I move that decimal point twice, that would be 65%. So those are the 3 forms. For number 15, we're supposed to shade the complement of F. That means not F. So that means we're shading everything that is outside of set F. So that's going to be a lot of coloring. Alright, now I apologize if you have OCD and I'm missing little spots because I don't have time to make this perfect. Alright, that's the best you get. Sorry. So, but this is a pretty good representation of the complement of F, everything that is not F. Now we need the probability of this, target over total. Okay, so how many do I have in the shaded region here? Okay, so here's F up here. So the numbers that are not F are the 10, the 5, the 7, and the 11. So that's going to be 33. Alright, so target over total, so 33 over 60. If I divide both of these by 3, that's going to be 11 over 20. Alright, so that's one form of the answer. Now if I do 11 divided by 20, alright, that's 0.55. Okay, so that's another form of the answer. If I move the decimal point twice, that is 55%, which is the third form of probability. Alright, I accidentally went slightly out of order there. I did number 13. I did number 15 before number 14, but let me not forget it. We're supposed to shade F or B or S. So this is all union, so that means we're just going to shade all of each of these. So F or B or S, we're just shading everything that's in F or B or S. Okay, and then one more time we are being asked for the proportion or probability of this. So again, we're going to do target over total. So what are the numbers in here? Okay, so this is everything except for the 11. So if I do 60 minus the 11, that should be the total that I have here. So that's going to be, what, 49? So target over total is 49 over 60. This does not reduce, so this is going to be one form of the answer right there. So now let's go ahead and get the decimal by doing 49 divided by 60. Okay, so that's 0.8167. I'm going to round up. 0.8167. Okay, so that's approximate, but that's another form of the probability. And the third form, if I move the decimal point twice, is going to be 81.67%. That's the third form of our probability. Alright, and then again, we already did number 15, but we did it out of order. Sorry. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.